All right, welcome to the Language of Algebra. These are just some vocabulary terms that you probably need to know and that I will be mentioning in class. So a variable, a letter that represents a number whose value may change. So we're talking X, Y, Z. And honestly, we just use variables because it takes extra time to draw happy faces. So X is just much quicker to write. But if we wanted to use a happy face, we could. It just stands for something that we don't know. A constant is a number whose value is always the same. So here's an example of a constant. There's another example. Any number is an example of a constant. This right here could change. It could be 4, 5, 6. It could be anything. But these guys always stay the same. Just a refresher, there are 4 basic operations: add, subtract, multiply, and divide. And these are just the different ways that you could see addition, subtraction, multiplication, and division represented. And the big thing that I really want you to get on this page is I want you to get this right here. The word for sum means addition. The word difference means subtraction. The word product means multiplication. And the word quotient means division. Okay? You will see division in many ways. Same thing with multiplication. You're going to see it a lot of different ways. Sometimes we use parentheses, sometimes we don't use parentheses. But with division, the preferred way to show it is like that. This way right here, A/B, sometimes those slashes can get awfully vertical and it looks like A1B, and that's bad. So I prefer stacked. This is called a stacked fraction, A over B. It just looks cleaner and there's no misinterpretation that's going to happen with that. Again, just a review, equal sign. It truly does mean equal. Like, I think that sometimes people think that I'm kidding, but whenever I say these two things are equal to each other, like if I were to write something like this, x is equal to 7, that means that x is 7. Okay, so equal truly does mean equal. The inequality symbols, I always read them from left to right. And you look at the smaller side. So if the smaller or the pointy side is on the left, then that is less than. If the bigger side is on the left, then that is greater than. All right, so here's some other symbols that you will need to know for this class. So if you start taking notes, you might want to take a note of this page or make a copy of it or take a picture, whatever you want to do. But these are things that I will expect you to know in the classroom. All right, so if I translate these from algebra into English, no big deal. You just write down what you read. 17 is, key word here is. You have to put that is in there or else it doesn't mean the same thing. 17 is less than or equal to 26. On part B, 8 is, notice how there's a slash through that equal sign, not equal to 17 minus 8. Or you could say the difference of 17 and 8. Part C, 12 is greater than 27, or you could say the quotient of 27 and 3, or you could simply say 27 divided by 3. And on part D, you can say y plus 7, or you could say the sum of y and 7. Lots of ways to write that correctly. Y plus 7 is less than 19. Grouping symbols are pretty important for you to understand because of the order of operations. You have to understand that with order of operations, we always do grouping symbols first. So you need to know what these grouping symbols can be. And these are just 3. This is not a full list right now. It's just a partial list of the different types of grouping symbols you can see. And so we could use parentheses, brackets, or braces. And with the order of operations, we would do what's inside of that first. The big idea on this page is that I want you guys to see that expressions do not have equal signs. So you're not going to see an equal sign on this page because every single one of these is simply an expression, and expressions can have any of the 4 operations. And pay close attention, at least read through the English phrase that goes along with this. So you might want to hit pause here. Okay, notice how on this page every single one of these guys has an equal sign. So that means that these are equations. And again, you can have all 4 operations here with an equal sign, and read through the English sentence that goes with each one of these, and make sure that you contact me with any questions that you might have. All right, so on these we are going to determine if each is an expression or an equation. The key here is equations have equal signs, expressions do not. So on part A, notice the equal sign. So this is an equation. On part B, there is no equal sign, so this is an expression. Part C, there's no equal sign, so this is also an expression. And part D, there's an equal sign, so this is an equation. All right, so exponential notation. It's important that you understand that your exponents are a superscript written in the upper right of the number. So your base is the bigger number. So in this first one, the 7 is my base, and my exponent is the 2. Now I want you guys to be ultra careful. This is a place where I'm going to be very picky with you this quarter. You have to make sure that your exponent truly looks like an exponent, because if it looks like this, I will count that as 72 and not 7 to the 2nd power, okay? So make sure that your exponent is small and it's in the upper right-hand corner. Don't do it like that. All right, so on this one, we're going to simplify 3 to the 4th power. I really hope that in your head you're not thinking 12, because that does not mean 3 times 4. This means 3 times 3 times 3 times 3, 4 times. So 3 times 3 is 9. And then I can multiply these guys, and I get 81. 3 to the 4th power is 81. Now, if you're typing this into your calculator, oh, I didn't put a calculator picture on here. That's okay. You would type in the number 3, then you would hit this button on your TI-30X2S button or calculator. Then you would hit 4, and then you would hit either the enter or the equal sign. And then it should give you 81. I do want you to practice this with a calculator. These are not the kinds of arithmetic problems that you want to be doing in your head. It takes too much time. All right, so order of operations is a big deal. I've already mentioned it once in this video. So step 1, parentheses and other grouping symbols. Then you do the exponents. Then you do multiplication and division in order from left to right. So that means if division comes before multiplication, whenever you're reading it from left to right, you would do division first. So if I have something like this, I do not do multiplication first there. I do the division first because you read it from left to right. So I would do 12 divided by 3 is 4, 4 times 4 is 16. Otherwise, if you did it the wrong way, if you did this first, you would get an answer of 1, and that is not correct. The nice thing about your calculator is that if you are using a TI-30X2S, then that calculator does understand the order of operations. You can type in the entire expression, as long as it doesn't have variables, and it will actually give you the correct answer. All right, so anybody that took high school math probably saw and heard about my Aunt Sally. So please excuse my dear Aunt Sally. This is just an easy way to remember your order of operations. The please stands for parentheses or any other grouping symbols. Excuse stands for exponents. My dear, multiplication and or division. Aunt Sally, addition and or subtraction. All right, so on this, we want to do the order of operations. Now you have to be really careful. In part A, you would do multiplication before you do addition. I used to get in the habit whenever I was younger of underlining what I would do first. And so that way I would remember, oh, I've got to do 3 times 7 before I add 4 to anything. So I want to do 3 plus 3 times 7 is 21, and I get 25 as an answer. All right, but look at what the parentheses do to this. The parentheses say, now I have to do this first. So I've got to do 4 plus 3 before I multiply. So 4 plus 3 is 7 times 7, and I get a different answer. I get 49 this time. So you see how order of operations can change the value of anything. If you don't follow the order of operations, you will not be getting the correct answers. Try these on your calculator. There is a parenthesis button on your calculator. There's an open and there's a closed parenthesis. I think they're above the 8 and the 9. I don't have my calculator in front of me, but take a look at that and try it out. Use those parentheses and test this. Try both of these problems on there and make sure you get these answers. All right, with this problem, we are going to do the parentheses first, just like the order of operations says. So we're going to do 5 minus 2 first. So I'm going to write down everything else just like I see it. 5 minus 2 is 3. Okay, now look at the operations that are left in this problem. I've got division right here. I've got addition right here. And I've got multiplication right here, 4 times 3. Remember, multiplication can be written using parentheses. So according to order of operations, I have to now do multiplication and division in order from left to right, okay? And so I'm actually, because they don't touch each other or overlap in any way, I'm going to do them at the same time. So I'm going to do this and this at the same time. 18 divided by 6 is 3. Oops, I'm sorry, I need to actually do that. 4 times 3 is 12. Now I can do my addition. So I get an answer of 15. All right, so to evaluate an expression, it means to find the value of the expression when the variable is replaced by a given number. So I'm going to tell you what x, y, z, whatever the variable is. I'm going to tell you what that is, and I'm going to expect you to substitute that into an expression like this. All right, so we're going to evaluate 7x minus 4 when, and you do these separately. We do A separate from B. So I'm going to substitute in 5 where I see x. So I'm going to rewrite the problem. This is important. Don't get lazy. Don't just write down the answer. Rewrite the problem and substitute it in. But I do want you to be very careful. Don't write 75. That's not what that means. 7x means 7 times x. So make sure that if you write it like that, you write 7 times 5 minus 4. 7 times 5 is 35 minus 4, and I get 31. Okay, so now, again, I ignore part A and I do part B separately. So now I'm going to substitute 1 in where I see x. So I've got 7 times 1 minus 4. 7 times 1 is 7 minus 4, and I get an answer of 3 this time. All right, on this expression, I'm going to evaluate when x is equal to 4. So on the first one, on part A, I am going to evaluate x squared. So I'm going to let x equal 4 this time. So I've got 4 squared. That does not mean 4 times 2. That means 4 times 4, which is 16. When you're doing this on your paper, you do not have to write down this step right here. I am just writing it down for education purposes, but you don't have to write that step down. All right, so the next one, I'm going to substitute 4 in for x. So I've got 3 times 4, and I get 12. Okay, so now the expressions are getting just a little bit tougher. I'm going to substitute 4 in everywhere that I see x. So I've got 2 parentheses, 4. Close your parenthesis before you put the exponent out there. That's really important whenever you have negative numbers. Trust me on this. Plus 3 times 4 plus 8. Now, according to order of operations, I have to do the exponent first. That does not mean 2 squared as well. It just means 4 squared. So I've got 2 times 4 squared is 16 plus, and I can go ahead and do this operation as well. Now I'm going to do 2 times 16, and I get 32. And now I do addition left to right. 32 plus 12 is 44. 44 plus 8 is 52. All right, so identifying what a term is. Term is a constant or a product of a constant and one or more variables. So here are some examples of terms. So they could be letters, they could be numbers, they could be a combination of variables and constants together. But those are examples of terms. The coefficient of a term is the constant. So in other words, that's the number that's in front of the variable. Just so you know, if you have this as a variable, its coefficient is the number 1. We don't usually write 1. It's understood to be there though. All right, this is a biggie right here. Like terms. The terms are either constant or they have the same variables raised to the same powers. That's important. X squared plus x are not like terms because they don't have the same exponents. So you actually can't do anything to this expression right here because they are not like terms. All right, so on this example, we are going to identify the coefficient. So on part A, the coefficient is simply 14. On part B, the coefficient is 15. Notice how I'm ignoring the exponent. It's not what they asked for. They didn't ask for the exponent. They asked for the coefficient. Coefficient is the number in front of the variable. On part C, that's like our x that we had a while ago. There is an understood 1 right here, so its coefficient is 1. All right, so I'm going to identify my like terms here. Let's see here. So I'm going to say y to the third power is a like term with 4y third, to the third, sorry. Okay, so I've used up those two. I'm going to mark through them. All right, the other like terms, let's see here. I've got, and I'm going to put an and symbol in between there. Those are the only two like terms right there. So now I've got 7x squared and 5x squared. These guys are like terms. I've got 14 and 23. Those are like terms. And this 9x, it doesn't have a like term. There's nothing that is the same. All right, so when you are asked to simplify like terms, that means you simply add and or subtract, depending on what's going on in the problem, the coefficients. That's all you have to do. So the first thing I do is I identify my like terms with the same number of underlines. So this one and this one are like terms. This and this are like terms. And then this and that are like terms. So I am going to combine 2x squared plus x squared. And remember, you have to add or subtract the coefficients. So 2 plus 1 is 3, so I get 3x squared. Now, what I've always done is I've always marked through them to show that I've used them up, and that way I don't accidentally leave something out. So now I'm going to combine my double underlines. 3x, that's a positive 3x because there's a plus sign in front of it, minus 4x. What's 3 minus 4? It's negative 1. So I could write either negative 1x or I could just put negative x because remember there's an understood 1 there. And then I'm left with positive 7 plus 5, which is 12. Terms are separated by pluses and minuses. So make sure that if it's a negative number, you put a minus sign in front of it. If it's a positive number, you put a plus sign in front of it. All right, so this page is a page that you may want to hit pause and just at least read through on your own. I'm not going to read it to you, but there are a couple of things that I want to point out to you. Notice how it says B less than A. Notice how there is no is in that. It doesn't say B is less than A. It just says B less than A. That phrase right there requires that you reverse the order. And so it would look like this, A minus B. This one right here also requires that you reverse the order, B subtracted from A. So just remember that with subtraction and division, order matters. With addition and multiplication, order does not matter. All right, so we're going to translate these from English into algebra. The difference is a fancy word for subtract, and this one is not one where I have to reverse the order, so I'm just going to write the order the way that I see it. So I've got 17x minus 5. Quotient is a fancy word for divide, and I like to use the fraction bar, so I'm going to say 10x squared over 7, just like that. Now, notice how I kept the order correct. You always write from top to bottom, so 10x squared had to go on top, 7 had to go in the denominator. 17 more than y? More than, I could write it like this, so more than means plus, or I could write it like this, because remember, with addition, order does not matter, so I would accept either one of those for full credit. Now in part B, 9 less than 9x squared. Now with this one, order matters, and less than is one of those phrases where you have to reverse the order. So you would do 9x squared minus 9. It cannot go the other way. It does not work like that. All right, 5 times the sum of m and n. This one right here implies that I want 5 times whatever you get whenever you add those guys together. So in order for you to do addition first, you're going to have parentheses. So I want 5 times the sum of m and n. It has to look like that. You have to have the parentheses. Now this one is a little bit different. The sum of 5 times m and n. So I want 5 times m, and then I want the sum of that and n. I always thought that this one, part B, was a little bit tougher than part A, but that is correct right there. Okay, the length of a rectangle is 6 less than the width. So if I have a width, that's that. Probably wrote that a little bit backwards, but that's okay. So here's my width. I got it flipped over on its side. It says the length is 6 less than, so this would be W minus 6 right here. Let W represent the width, write an expression for the length. So here's my length right here. It's 6 less than. All right, so June has dimes and quarters in her purse. The number of dimes is 3 less than 4 times the number of quarters. Let Q represent the number of quarters. Write an expression for the number of dimes. So the number of dimes is 3 less than, so minus 3, 4 times the number of quarters. So 4 times Q. There you go. That's how many dimes she has. All right, so that's it for this lesson. If you have any questions, please email me and I'll be happy to get back with you.